Bismillahirrahmanirrahim. Dear students, in the previous lecture number 20, I told you about the electrolytic cell. This is electrolytic cell and preparation of sodium hydroxide, caustic soda, by using brine. Brine is a concentrated solution of sodium chloride. And I told you that three products are going to be formed. One is the chief product, main product, sodium hydroxide, and hydrogen gas and chlorine gas as a byproduct are going to be formed here. So this is sodium chloride solid dissolved in water. Water also give hydrogen ions and hydroxyl ion. Sodium ions and chloride ions are going to be formed. So four ions you have: hydrogen ions, sodium ions, chloride ions, hydroxyl ions. So this cell is called a Nelson cell. So I put question mark yesterday. I put question marks in the lecture number 20. So hydrogen and sodium chloride and hydroxyl, which ion from the positive and which ion from the negative are going to be collected at their electrodes. So we have to discuss this one. Dear students, first of all you have to write that name of the electrodes same as graphite acts as an electrode, anode, graphite anode and cathode iron. Steel iron acts as a cathode here. So I will explain the diagram also. What explanation is here? If you see the page number 174 page, preparation of sodium hydroxide 7.62 article. So during the electrolysis, when we pass electric current, 4 ions I told you. So written here, chloride ions will go towards the cathode. Add anode. Chloride ions will collect to give a chlorine gas by the loss of 2 electrons. So at anode you can collect chlorine gas, not hydroxyl ion. Hydroxyl ion will not collect. This is due to the electrochemical series and also concentration. This is due to the electrochemical series you will learn in the higher classes and also concentration. In other words, there are 2 positive ions yesterday I told you, hydrogen and sodium ions. So sodium ion will not collect. Sodium ion will not collect at cathode. It is written in your book. However, sodium ions do not reduce to form sodium metal at cathode. Reason is given also because the water molecules are more easily reduced than sodium ions according to electrochemical series. Water molecules reduce easily than sodium ions according to the electrochemical series. The sodium ions do not collect at cathode to make a sodium metal. So at cathode here anode oxidation and cathode reduction. So water molecules. So what you write in this form? This is the covalent bond between the hydrogen and OH ions. So this water is going to be reduced here. So 2 molecules of water by gain of 2 electrons. So these hydrogen ions, they are going to be reduced to give a hydrogen gas. These 2 hydrogen ions from water, this bond is broken down between water, hydrogen and hydroxyl ions. So 2 hydrogen ions to make a hydrogen gas, and hydroxyl ions remain in the solution. There is no change in the hydroxyl ions. So hydrogen ion change into hydrogen gas according to the electrochemical series. So sodium ion do not collect at cathode. The reduction of water molecule produces hydroxyl ions and hydrogen gas. I have written here. Thus the electrolytic, the sodium becomes sodium hydroxide. After that I will write. Now if you are going to add these 2 off-cell reactions, 2 electrons from the oxidation, 2 electrons from the reduction are going to be cancelled out. So this is the water, hydroxyl ions, hydrogen ion plus chloride ions in aqueous solution to make chlorine gas at anode. Hydrogen gas will collect at cathode and the hydroxyl ions remain in the solution. So, dear students, the concentration of hydrogen ions decreases. Concentration of chloride ions also decreases during the electrolytic process, because continuously the hydrogen ion to form a hydrogen gas and chloride ion to form a chlorine gas, the concentration of hydrogen ions going to decrease and concentration of chloride ion also going to decrease. So what kind of ions remain? So in the cell you are finding sodium ions and hydroxyl ions. Because these both ions are not going to be changed. They are remaining in the cell. So when these hydrogen ions and chloride ions are going to be finished to make a hydrogen gas and chlorine gas, so sodium ions and hydroxyl ion will accumulate, collect. Because of there is a perforated tube. If you see the diagram, I will explain also here. There is a perforated tube. Down there are small cuts, small holes like this one. There are cuts here. So sodium ions and hydroxyl ions, they pass from here and we will collect here sodium hydroxide in aqueous form, in the liquid form, in the catch basin. So sodium hydroxide will be collected in the catch basin because of hydrogen ions and chloride ions, they are going to be finished. And sodium ions, chloride ions only they are going to be, so they will collect here. From this there are cuts, perforation, and they will pass through these cuts, and there the catch basin, there is a container collector, so we collect sodium hydroxide in the form of liquid, then we are going to change it into solid, very small patches. So I will explain. First I have to write this equation. So again I am telling you, dear students, we use anode graphite cell as in the previous method, and iron steel is used as a cathode. So anode, and I told you there are 4 ions in the solution: hydrogen ions from water, chloride ions from the sodium chloride, sodium ions from sodium chloride, and hydroxyl ions from the water. So 4 ions. And in the previous lecture I told you there is a question mark that which ion will collect there. So according to electrochemical series, chloride ions will collect at anode to make a chlorine gas, and water will go towards the cathode to make hydrogen gas, and hydroxyl ion remain in the solution. Sodium ions will not collect at the cathode. So hydrogen ions and chloride ions concentration is going to decrease because continuously we prepare hydrogen gas and chlorine gas. So only the two ions are remaining in the container. These are the sodium ions and hydroxyl ions. So their concentration is more, and they accumulate, they collect in the container, in the cell. So this is the tube which has perforation, small cuts, small holes. So these sodium ions and hydroxyl ions, they pass through these cuts and they fall in the catch basin, they collect in the catch basin collector. So in the form of liquid we collect sodium hydroxide. So I think this is clear for you, and I told you that in every lecture I am reminding you that you should open your book. You should have the pen, pencil and also copy, and your book should be ready while the teacher is going to teach, because you will learn more if you have book, you have consult your book. So this is the process. Now write this chemical equation. This is not given here. So these are the sodium ions remaining in a cell, hydroxide ions remaining in the cell. So they change into sodium hydroxide. If you evaporate, heat, small heat, not high temperature, you will get a solid sodium hydroxide, white solid sodium hydroxide, and it is in the solid state. So in the laboratory, if you see in the small packets, small tablets, it's present, it's hygroscopic. Sodium hydroxide is hygroscopic because if you put in the open air without any lid, so it is going to be absorb water from the atmosphere, so it is going to be liquid form. Melt it, hygroscopic, absorb moisture. And another property of sodium hydroxide is if you put in the water and you stir up, this is the exothermic process, and the bottom of the beaker is going to be increased, the temperature is going to be increased while dissolving sodium hydroxide in the water. Exothermic is very important compound in many industries, mostly in the soap industries it is going to be used, and there are other uses. Soap preparation, sodium hydroxide, potassium hydroxide. They are very important compounds. Chlorine also very important. Hydrogen is also very important. As a byproduct, chlorine and hydrogen are also prepared in this process. So dear students, if you see page 174 I told you, there is a diagram, Nelson cell. The process is a Nelson cell. In the Nelson cell, you have a container, big container. This container contains brine, sodium chloride in water. So I told you there are 4 ions are there. So in the center of this diagram, you can see black carbon graphite at the anode. Graphite acts as an anode, and there is a U-tube like this one, perforation, the same you will find in the center of this diagram. So there is a down here collector, like this one, you will find the collector down here, and hydrogen gas is collected at the cathode and chlorine gas is collected at anode. So perforated steel acts as a cathode. Perforated steel, iron is going to be acts as a cathode here. You can find in the center, and the aqueous solution of sodium hydroxide is also formed when you are going to pass electric current, because we are talking about electrolytic cell. Electrolytic cell means electrical energy derived change into chemical energy. So this is a non-spontaneous. Continuously you have to apply the electric current. So finally, I am telling you again and again, during the process, concentration of hydrogen ions and chloride ions will be decreased for the formation of chlorine gas and hydrogen gas. They collect respectively at their electrodes. So when the concentration is going to decrease, the concentration of sodium ions and hydroxyl ion going to be increased by the perforated steel. There are small cuts here, so they pass. These ions pass and accumulate in the container, and sodium hydroxide is going to be prepared. So you can see this diagram for the 7.11 Nelson cell. So in the last, these sodium ions in aqueous, hydroxyl ion in aqueous, they are going to be collected in the bottom here, catch basin in the collector. Then small evaporation heat, water will be evaporated and you will get solid sodium hydroxide. So it's very important method for preparation of sodium hydroxide as well as hydrogen gas and chlorine gas. So go through this one. These are the very important. And in the previous lectures also I told you that from the board the question may be asked in the parts, fractions. This topic can be divided into many parts. Sometimes the examiner asks you, write down the chemical equations involved in this process. So only write the chemical equations including this one, and other also I wrote. Sometimes they ask, write down the name of the products which is going to be collected at anode and which is going to be collected at cathode. And maybe they ask question that why not sodium ions collect at cathode? Why water? This is according to the reactivity, according to chemical series. Write down the products, which is a major product and which are minor products. What's the name of the anode and what's the name of the cathode? So make these small notes in your copy. Just remember this and you have to explain this. Sometimes this diagram also asks. So maybe the examiner prepare short questions from this. Maybe he prepared long answers, long questions from this. So it is choice for the examiner. So you have to summarize it, write down important points, remember them, then you have to explain. So if you know, so any questions can be asked and you can give the answer. So this is about the manufacture of sodium hydroxide by using brine. Brine is a concentrated solution of sodium chloride. Brine is a concentrated sodium of sodium chloride. This is electrolytic cell. Now, if you see the previous topics, what are the uses? Page number 173, manufacture of sodium metal from the fused sodium chloride we done. And we done also manufacture of sodium hydroxide from the brine. Then another very important topic, electrolytic refining of copper. Electrolytic refining of the copper. So I am going to start this one. In the next lecture, I will give you a full description for this one. So thank you very much.